In question 7, part A, we have to prove the identity sine upon sine plus cos upon sine minus cos as tan square plus 1 and tan square minus 1. So we'll start off by taking the LCM. In the new denominator, the LCM will become sine plus cos and sine minus cos. The sine will multiply by sine minus cos, and this cos up here will multiply by sine plus cos. Opening up the bracket, we'll get sine squared minus sine cos. Cos into sine will again become sine cos plus cos squared divided by sine plus cos and sine minus cos. Now minus sine cos and plus sine cos will cancel out. Over here, as we have sine plus cos and sine minus cos, we can apply the algebraic identity, that is a plus b and a minus b equals to a squared minus b squared. So we can write this as sine squared plus cos squared divided by sine squared minus cos squared. Now, if you look at the expression, we needed to bring it in terms of tan. So to bring it in terms of tan, this sine must divide by cos. So if I divide the whole equation by cos squared, so let's say if I divide this sine squared by cos squared, I will have to divide every term in this expression with cos squared. So dividing every term in the expression with cos squared, I will get in the denominator sine squared upon cos squared minus cos squared upon cos squared. So cos squared and cos squared will cancel to become 1. And sine squared upon cos squared is a tan squared. So this will become tan squared theta plus 1 in the numerator. And sine squared upon cos squared is again tan squared. So tan squared theta minus 1 in the denominator. In part B, it is asking us to solve to find the exact solution of the equation sine upon sine plus cos upon sine minus cos equals to 2. Now we have proved that this is equals to tan square plus 1 divided by tan squared minus 1. We can put it in the first step equals to 2. Cross multiplying, we'll get tan squared plus 1 is equals to 2 tan squared minus 1. So taking the tan squared on this side, this will become 2 tan squared minus tan squared equals to 2. So tan squared will be equals to 2 and tan inverse. So this was a 2 up here. So this 1 would have become a 2. So this will be a 2 up here. So taking 2 on the other side, this will become 1 plus 2. So tan squared will be equals to positive 3. Now once to find tan theta, we'll take the square root of 3. So taking tan inverse of square root of 3, now as when we have a square root, we have a positive and a negative value. So we'll write tan theta is equals to square root of 3 and tan theta is equals to the negative square root of 3. So we'll have positive and negative values of tan. Now taking tan inverse of square root of 3, that will give us the basic angle. So the basic angle will be equals to tan inverse of square root of 3 is pi upon 3. Now, as the range of theta is from 0 to pi, so if we make the quadrants to find the angle theta, we'll make the basic angle in the positive quadrant of tan from 0 to pi. So the first quadrant is positive for all the trigonometric ratios. And as tan is also negative, so we'll also take tan in the negative quadrant. So tan is negative in this quadrant. So we'll make the basic angle over here as well. So the two values of theta will be from the positive x-axis anti-clockwise. So the first angle for theta will be pi upon 3. And the second angle will be pi minus pi upon 3. Simplifying pi minus pi upon 3, that will become 2 pi upon 3. So the values of theta will be pi upon 3 and 2 pi upon 3.